So my name's Ben Salins. I'm a designer and project manager at Partisans, a local firm here. I'm going to walk through essentially a case study of just one building in particular where we uh, found or we built up complexity through a kit of parts and essentially how we walk through the full process of actually finding fabricators who can make digitally crafted uh, assemblage of parts. So the project in general is Gusto 501 here in Toronto. It's a restaurant located on 501 King. It's actually opening up this week again, the patios, if you want to go support a local business. Um, the the concept for the project had two parts. One was drawing upon influences from the client's first restaurant, Gusto 101, which was built from a retrofitted auto body garage included retractable roof. So you can see here this image to the left was kind of drawing upon that, where we started to play with different ways where we could actually fold up the facade and open up the space. The second idea was to have a carved out interior using a material that was both special and personal to the client's story. The client, Janet, spent much of her childhood in Italy with her father, who often used terracotta as a building material. We wanted to draw on these two concepts to give like the airiness, the texture, the materiality of being in an Italian piazza. So the final overall building, on the right you can see the section of the building. So to achieve the design for that terracotta, which you can see in red kind of flowing up through the building, we both took a top-down and a bottom-up approach with the design. In other words, we had somewhat of an a priori notion of what we wanted this wall to look like and how it would function, but we also relied on simple building blocks and their relationships to each other to establish an overall set of rules for how the overall form would come together. To the left, you can see building sections with the red terracotta, with the where we start to see corbelling up the space. You can start to see the relationship between block to block where they step out and start to cantilever out into the space. A lot of how much it was corbelling was actually dictated on where it was in the design. So where we needed more floor space, we would kind of squeeze it and allow it and become as minimal as possible. And then where we had double height spaces, we would often corbel out to create more of a dramatic effect. So here you can actually see kind of the building blocks themselves. We didn't have like a huge budget for this project, so we had simple constraints just to start with, but we had ambitious goals. So in order to stay on budget, we worked with an off-the-shelf structural clay tile. These are common extrusions used all over the world. We found a local fabricator, fairly local, down in Ohio. You can see the simple extrusion they have in the bottom left. And what we ended up doing is we essentially set 3 different angles and then cut the block at 6 different depths to make an overall 18 different types, so we can get an assemblage of these parts. And then we could flip them, we could reverse them, we could manipulate them within a confined set of rules to kind of get that complexity we were looking for in the original design. So this Ohio-based manufacturer, they were actually really great to work with. We went through a couple iterations on how we would actually accomplish this. In the end, we ended up going with a process where they actually wire cut these blocks and both saved time because they were able to do it just coming off the assembly line. It ended up saving us on logistics. We aren't sending these to a separate place to get cut. You're saving space on site. It's a fairly tight site to begin with. And we could just have them shipped directly as needed to the masons who could take it to site and work and start their work from there. So once we had our kit of parts, we actually had another round of value engineering taking place where we actually needed to, again, bring these budgets down. So the cut blocks cost about 3 times as much as a normal block. So we kind of optimized the overall form to use as few cut blocks as possible in order to both streamline the structural design of the form, but also to save that money. We pretty much saw this as another constraint and integrated some additional areas of flat block. Overall, it ended up kind of grounding the design a bit. We're now able to see the flat block as pretty much a datum from which you can understand the difference, the extent of the corbelling, to really emphasize that how much we varied that the extremeness of the forms. The next step came with working with the masonry trade to fabricate a prototype. In addition to verifying certain aesthetic considerations, such as what it actually looked like, the color of the mortar, whatnot, we also were able to understand the process with which they were building. We couldn't have found this more helpful to actually how we created the construction document. It really helped us inform a way of communicating to them in a way that they would actually be building it. To throw kind of one more curveball into design, we actually decided to integrate lighting into the block work. So we could illuminate the walls and create this kind of glow of terracotta within the space. It took a bit of research, but we found a unique LED product which we could have lights mounted at any location along the length of the wire. So we could have the mason routine install low voltage wiring into the grout, and then the electricians would follow and were able to clamp the lights on wherever the wire was exposed and available to them. So the next question was, how do we actually communicate this level of complexity to a trade that's literally building this block by block? Our solution was to give a small set of rules for how the blocks relate to each other, i.e. block cell walls always stack, limit the corbelling to one cell per row, and then amount of grout thickness deviation, because these blocks weren't perfect to begin with. And then we essentially laid out a quote-unquote simple package with each row by row, grid line to grid line, which they could just work in succession and go and build this throughout the whole process. We were able to just hand off this package, and it ended up being one of the easier parts of the actual construction process because of the thoroughness of the package. We actually had fewest amount of questions with the masonry team compared to every other trade, probably. So as a result, so again, on the left, you see the exterior, Core-10 panels cladding the glass door, and then on the right, you see the view of the entry down from the second floor. This is a view of the second floor bar space. Here on the left, you can see some of that, the corbelling starting to happen. It gets as thin as like one cell block where the stair passes through. Again, there was a lot of code constraints that we had to negotiate with all of the block wall in order to allow people to pass, allow certain clearances, this is barrier-free and whatnot. And then a couple detailed shots. Some of the details that were built into the algorithm, such as the subtle stepping, subtle things that didn't line up, were all intentional. With such a limited set of parts, we just wanted the amount of, as long as it was clear and consistent, we found that it would be coherent in the overall design. Again, here you see the corbelling coming up the stairs, and then going back to that hyper garage idea, you can see we ended up having the glass where the first and third panel actually counterbalance each other and stack behind the second one. And that's it.